Hello everyone and welcome back guys to Mathematical Mindset. So right here we have this amazing Math Olympiad problem that says a raised to the power of 2 minus a raised to the power of 3 is equal to 150 and we have to find the value of a. So right here guys, we want to simply solve this, but the first thing we want to do is that we know that we can easily write 150 to be equal to 125 plus 5, right? So this is going to give us this. Now the reason why we are making use of this is because we want to simply express the both number in terms of 5. So expressing this in terms of 5, we have this to be 5 raised to the power of 3 plus 5 raised to the power of 2. Alright, so this equation is going to become a raised to the power of 2 minus a raised to the power of 3 is equal to, so in place of 150, we are going to make this to be 5 raised to the power of 3 plus 5 raised to the power of 2. So rearranging this equation and set it to 0, we have this to be a raised to the power of 2 minus a raised to the power of 3 minus into 5 raised to the power of 3 plus 5 raised to the power of 2 is equal to 0. Alright, so from here we have this to be a raised to the power of 2 minus a raised to the power of 3 minus multiply 5 raised to the power of 3 will give us minus 5 raised to the power of 3 minus multiply plus is minus, so 5 raised to the power of 2 is equals to 0. Alright, so arranging this, we have this to be a raised to the power of 2 minus 5 raised to the power of 2. This is going to be all square minus into a raised to the power of 3 plus 5 raised to the power of 3 is equals to 0. Now the reason of this plus is because if we multiply multiply a raised to the power of 2 will give us minus a raised to the power of 3, and minus times plus is minus, which will give us 5 raised to the power of 3. So we have this right here. So the next thing we want to do is to simply apply the difference of 2 squares and also apply the sum of cubic formula. Alright, so applying this, and we have the difference of 2 squares to be a square minus b square. This is equal to a plus b multiply a minus b, and we have the difference, the sum of cubic formula to be a raised to the power of 3 plus b raised to the power of 3 is equal to a plus b multiply a square minus ab plus b square. So we want to simply apply this formula to this. Alright, so we say for a square minus 5 raised to the power of 2, so we have a square minus 5 square. This is equal to a plus 5 multiply a minus 5, and we have for a raised to the power of 3 plus 5 raised to the power of 3. This is equal to a plus 5 multiply a square minus a is a multiply what is b, we have b to be 5 plus b square, which is 5 square, and this is equal to a plus 5 multiply a square minus 5a plus 5 square, it is 25. Okay, so hence the equation becomes a plus 5 multiply a minus 5 minus, we have a plus 5 multiply a square minus 5a plus 25, and this is equal to 0. So from here, we want to simply factor out the common term. So factor out the common term. We have the common term to be a plus 5. So we have this to be a plus 5 into, if you factor out a plus 5, we have this to be a minus 5 minus, we have this to be a square minus 5a plus 25, and this is equal to 0. So we are going to have this right here. So from here, we have this to be a plus 5 into, want to simply open up this, we have a minus 5 minus multiply a square will give us minus a square, minus multiply minus 5a will give us plus 5a, minus multiply plus 25 will give us minus 25, and this is equals to 0. So we have a plus 5 into, so rearranging this and bringing a square to be the first, so we have this to be minus a square plus 5a plus a minus 25 minus 5, and this is equal to 0. So we have a plus 5, I'm just going to change this bracket, a plus 5 into minus a square, 5a plus a will give us plus 6a, minus 25 minus 5 is going to give us minus 30, and this is equals to 0. So from here, we want to know that if we have a multiply b equals to 0, this implies that a is equals to 0 and b is equals to 0. So applying this, we have this to be a plus 5 equals to 0, and we have minus a square plus 6a minus 30 is equals to 0. So for this, we have a is equals to 0 minus 5 and a is equals to minus 5. So we are going to call this a1, and this is the real root of the solution. Okay, so with this, some persons will stop here saying a is equals to -5 because it's a real root, and looking at the other part of this equation, it clearly shows that we are going to have a complex root, right? But let's just simply solve this to have the other values of a in this question. So right here, what we have to do is to multiply through by -1 to get rid of this negative sign. So this becomes -1 multiply minus a squared plus 6a minus 30, which is equals to 0. So -1 multiply minus a squared will give us a square. -1 multiply plus 6a will give us minus 6a. -1 multiply minus 30 will give us plus 30, and this is equals to 0. So solve using the quadratic formula. So using the quadratic formula, we have the quadratic formula to be given as x is equals to minus b plus minus the square root of b squared minus 4ac all into 2a. We have a to be 1, b is equals to -6, and c is equals to 30. So x is equals to minus into -6 plus minus the square root of b squared, which is -6 squared, minus 4 multiply 1 multiply 30 all into 2 multiply 1. So from here we have that x is equals to minus times minus is plus, so we have 6 plus minus the square root of -6 squared is 36 minus 4 multiply 1 multiply 30 is going to give us 120 all into 2 multiply 1 is 2. So we have x is equals to 6 plus minus the square root of 36 minus 120 will give us -84 divide 2. So x is equals to 6 plus minus the square root of 84 can be expressed as 21 multiply 4 multiply -1 over 2. Alright? So from here we have this to be x is equals to 6 plus minus. Now multiplication can be interchanged. So this is going to become the root of 4 multiply the root of 21 multiply the root of -1 over 2. But the root of -1 is equal to I, right? So this becomes x is equals to 6 plus minus the root of 4 is 2 multiply the root of 21i over 2. So we can easily factor out 2 from the numerator. So factor out 2 from the numerator. We are going to have this to be x is equals to, if you factor out 2 from the numerator, we have this to be 2 into 3 plus minus the root of 21i over 2. So this is going to cancel out. So we have x is equals to 3 plus minus the root of 21i. So we have x3 to be equals to 3 plus the root of 21i, or we have x4 to be equals to 3 minus the root of 21i. Alright, so right here in the quadratic formula, I made use of x, so which implies that x is equals to a. So we say if x is equals to a, so this becomes a3 is equals to 3 plus the root of 21i, and a4 is equals to 3 minus the root of 21i. So right here, guys, we have been able to find the values of a. So right here we can say hence we have the values of a to be the values of a. We have a1 to be equal to, so we simply want to recall what a1 is. A1 is -5, so we have a1 to be -5. We have a2 to be equal to 3 plus the root of 21i, and we have a3 to be equal to 3 minus the root of 21i. So we're going to call this a real root, and we have this to be a complex root. So we want to simply verify this using the real root. So we say to verify by making use of the real root, which is a1 is equal to -5, and we have the question to be a squared minus a cubed is equals to 150. So from here we have -5 all square minus into -5 raised to the power of 3 is equals to 150. Alright, so -5 squared is 25 minus, we have this to be -5 raised to the power of 3 is -125, and this is equal to 150. So 25 minus multiply minus is plus 125, and this is equals to 150. 25 plus 125 will give us 150, which is equal to 150. So we have been able to solve for this right here, and we have been able to find the values of a. So guys, if you really like this video, please do not forget to subscribe to Mathematical Mindset, give this video a thumbs up, and I'm going to see you in the next video.